Let's take a closer look at the structure of the thick filament. So the thick filament is the filament that's shaded orange here. And we're going to take a look at this portion, the lateral portion of the thick filament. We're going to zoom in on that. So here's a closer look at one portion of a thick filament. The thick filaments are made out of a protein called myosin. And so what they're doing in this picture is they're taking one myosin molecule and showing us what a myosin molecule looks like. So in other words, the thick filament is made of many myosin molecules assembled in a certain way. But just looking at one myosin molecule, you can see it looks kind of like a double-headed golf club where these two globular head groups on the end, they're known as cross bridges. What they have is a binding site for the thin filament, a binding site for actin, and they also have a binding site for ATP. And so this molecule is able to utilize the energy in ATP to move. And there are two places where the myosin molecule can move. It has a hinge right at the base of the globular head groups, and there's also a hinge on the tail portion. And so, big picture, the way that myosin molecules assemble the thick filament is that myosin molecules are placed together end to end. So let's say there's one myosin molecule and here's another. This is what I mean by end to end, so that the globular head groups are facing opposite directions. And there are many myosin molecules that are arranged like that. And hopefully this explains a little bit why the thick filament looks the way it does, which is that the globular head groups are going to be projecting out, spiraling out around the thick filament on the lateral portions of the thick filament, but then in the center of the thick filament, it's smooth. And so just to take another look at that, here's the thick filament in context with the rest of the sarcomere. And so we can see it's made out of many myosin molecules arranged in such a way that the central portion of the thick filament is smooth, and then the globular head groups project out from the thick filament on the lateral end. So on both sides, the globular head groups stick out. Remember, we said that the globular head groups have a binding site for actin for the thin filament. And, look at what is close by so we can, start to think about how this is going to work. Seems like that thick filament is going to be able to bind to the thin filament and use ATP. Let's use this animation to see how the myosin molecule can move. Here, the myosin molecule is bending at the hinge in the rod-like tail in order to bind to actin. And here we can see the hinge at the base of the globular head groups pivot and pull actin towards the center of the sarcomere. That action is known as a power stroke.